All right, our lesson on 1.6 part 1. We are going to solve absolute value equations today. A little flashback to absolute values though. So, what if, give you that problem. What are these bars called? Anybody? Absolute value bars. And probably somewhere in your memory bank, you have a memory of some teacher telling you the absolute value meant, quote, make it positive. Which is not wrong, it's just misleading because it doesn't mean mathematically you make it positive. When kids hear that, they think, oh, I'm going to make this 5 plus 2. The answer is 7. That's not how absolute values work. You compute the inside. So 5 minus 2 would be 3. So it's the absolute value of 3. The absolute value really means distance from 0 on a number line. So if here's 0 and here's 3, the distance between 0 and 3 is 3 units. So the answer would be 3. Now, what if I reverse that problem and I say the absolute value of 2 minus 5? So if I compute 2 minus 5, that would be a negative 3. And the absolute value of negative 3 would be the distance from 0. So this way, it's still going to be 3 units. So back when you were younger and your teacher said, quote, make it positive, they're referring to any computational answer that came out negative is now going to be positive. However, that's not really what's happening. You're measuring the distance from 0 on a number line. We never measure distance negatively. Your geometry teacher probably gave you that phrase a lot when you worked with the Pythagorean theorem. Distance is always a positive measurement. All right. So skip this top section. It basically says the same thing. And I want you to find, oh, before we look at the next problem, I have an idea. It's worked out well today. Let's see. I'm going to write an algebra problem down for you. That's an algebra problem. Yeah. So that thing, like a red squiggle, I'm going to call that blah today. Because that's exactly what algebra looks like to most people. A bunch of weird symbols, and that's exactly what algebra is. I'm choosing a variable or a symbol to represent something. So today, blah is what I'm using as my variable. So what does blah equal? 9. Anything else? Could it be anything else? Negative 9. This could also be negative 9. Okay. Well, what if I give blah a real name? And I call it 2x minus 5. 2x minus 5 could be 9. Or 2x minus 5 could be negative 9. So you're going to write a big note to yourself right here. You're going to set, up 2 problems. I don't know why I can't spell today, guys. So your 2 problems, 2x minus 5 could be 9, or 2x minus 5 could be negative 9. And you're just going to solve them independently, but the math should look identical as far as the algebraic steps. So for instance, first you're going to add 5. So you got 2x equals 14. And then divide by 2. So my first solution is x equals 7. My extra problem I had to set up. Same math. I'm still going to add 5. But because the original solution was different, it was a negative 9, we're going to get a different solution. So 2x equals, watch your negatives in your computation. A lot of your mistakes and your summatives have been right here. Negative 9 plus 5 is a negative 4. Still dividing by 2. So the other solution we get is x equals negative 2. So I just got a solution of x equals 7 and x equals negative 2. Which one is correct? They're both correct. Very nice. All right. Did you notice I did not change 2x minus 5? You never, 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 never change what's inside the absolute value bars. That thing stays. Whatever that algebra was. All right, big note at the top of this section. Could you please write a note to yourself that says that we need to make sure we isolate the bars. So whatever it is, the absolute value bars can equal something. But those bars have to be completely isolated. They can't have a coefficient in front. They can't have an addition or subtraction problem off to the side of it. It has to be totally isolated. So number 1, absolute value of x plus 3 equals 5. Bars are isolated. Check. Now I'm going to set up my 2 problems. X plus 3 could equal 5. But what else could x plus 3 equal? Could be negative 5. And then we solve. Yeah, you sure could. Separate your problems if you'd like. Some people put the word or in the middle. That's fine. I just don't want you guys to confuse the ors that we're talking about today with the ors of tomorrow. So remember, ors on a boat problems, we're going to talk about those tomorrow. All right, so we're going to subtract 3. Then x equals 2. First solution, same work, different solution though. When I subtract 3 over here, get x equals negative 8. So I just got 2 solutions. Which one's correct? Both. Whoops. Don't cross off your answers. That was an 8. All right, number 2. Good. The bars are isolated, so we are ready to set up our 2 problems. 7t plus 3, there's a fraction that pops up here, so could equal 4. What else could it equal? Negative 4. We have not changed anything from inside the bars. All right, I'm going to subtract 3. Fractions are numbers too, don't panic. We're going to divide by 7, and leave your first solution as t equals 1/7. Same math, different solution. Subtract 3, subtract 3. Now, some of your computations get a little crazy. Negative 4 minus 3 is negative 7. T is negative 1. Very nice. And again, 2 solutions, both correct. Need them both. I'm going to erase this problem just because I need a little more room, so I stay within my screen so our viewers on the internet can see it all. 1/2 t minus 4 inside the absolute value bars equals a 1. It is isolated, so I'm going to set up my 2 problems. So 1/2 t minus 4 could equal 1. What else could 1/2 t minus 4 equal? A negative 1. Very good. Okay. We're going to add 4. So right now I have 1/2 t equals 5. Very quick, efficient way to get rid of a fraction coefficient. Multiply by our reciprocal, which would be a 2 or a 2 over 1. Both sides, of course. So 2 and 1/2 cancel. Get t is 10. Good, good. Then, same math, different solution. Whoops, look what I just did. I'm not subtracting 4, I'm adding 4. 1/2 t equals 3. Same math, we're going to multiply by the reciprocal, so multiply by 2. And I get t equals 6. Again, both solutions are going to work for this problem. How could I check to make sure that these were indeed solutions? Plug it back into the original problem. Yeah, it does not take very long to do that. I know you're probably not going to do it now as we do our notes because you're just trusting that I didn't make a mistake. And you're probably also not going to do it on your homework. You're probably just going to check the key. I understand that. But let's say we take, oh, I don't know, a summative on Friday. I think it might be worth your while to go back and plug them in, make sure you're getting answers that work. Why not? All right. Questions so far? About to get exciting. Maybe. All right. Very first rule I had you kind of start at the top of this section was you must isolate the absolute value bars. This is not isolated. Yes, you should multiply by the reciprocal. Someone earlier today had an idea to distribute the 2/3. Technically, that's an okay move, but there's going to be a moment coming up where we are not allowed to distribute into the absolute value bars for a different reason. So just to break that habit, I always tell my kids, just don't ever distribute into bars. So the reciprocal of 2/3 is 3/2. So these guys cancel. And I have a new and improved problem, bless you, of absolute value 1 plus 2x. And then if I do a little computation here, it equals a 3. New problem, new day. Now I can set up my 2 problems. So 1 plus 2x could equal a 3. What else could 1 plus 2x equal? A negative 3. Good. Careful on your algebra here. You are going to start by subtracting the 1. And then you're going to divide by 2. Question out where this got it. Okay. Divide by 2 on both sides, so x equals 1. Same math, different solution. Subtract 1. So I kind of find these problems comforting in an odd way, because you're going to do like literally the exact same math twice. And if you notice you didn't do the same steps, something's wrong. So subtract 1. So 2x equals negative 4. Divide by 2, divide by 2. X equals negative 2. Good. Yes, ma'am. This part? So if you multiply the fraction 2 over 1 times 3 over 2, you could literally just type that on your calculator, but if you want to know why I'm coming up with the answer 3, the 2's cross cancel, and you end up with 3 over 1, which is 3. Yep. And there will be a moment when we really have to discuss how to do fractions without a calculator. We're not there yet, but it's coming. All right, number 5. I'm going to have to take a little extra space here, so I'm going to kind of work into number 6, and I'm going to flip to a new screen for number 6. So please try to squeeze your work a little smaller than I'm about to do. Are my bars isolated? No. You need to move this plus 5. So let's subtract 5. All right, so my new and improved problem is the absolute value of 2 minus 4x. Now it equals 5. Now you can set up 2 problems. So 2 minus 4x equals 5, but what else could 2 minus 4x equal? Negative 5, very good. If you're going to make a mistake, it's probably going to happen right here. I see we're going to subtract the 2. And then I get a lot of kids who lose this negative term. It's negative 4x equals 3. So then divide by negative 4. Leave your answer as a reduced fraction, so x equals negative 3/4. All right, same math, different solution. Subtract 2, subtract 2. Oops. We have negative 4x equals negative 7. And I haven't really been counting you wrong at all, because you're not wrong when you do this, but some of you are forgetting that when I divide a negative by a negative, my solution is now positive 7/4. All right. Bad news on number 6 here. Thank you. You've got 2 things you need to take care of. So you've got that 5 that has to be divided, and you've got that 3 that has to be added. Now, which one should I do first? The trick question. Technically could have done either. So there is one that's a lot smarter, though, than the other. If you were to divide by 5 right now, you would have 3/5 and 12/5. So unless you really love fractions, I don't know if that's a good first step. So maybe instead of dividing by 5 first, why don't we go ahead and add the 3? So I have 5, absolute value of 2 minus x, whoops, equals 15. Now what should we do with that 5? Divide. So divide by 5, divide by 5. All right, I'm going to have to go to another screen, but I see I do have absolute value of 2 minus x is equal to 3. Finally, I'm ready to set up my 2 problems. So my first problem is 2 minus x could equal 3. Where else could 2 minus x be? Negative 3. You got this. Subtract 2. Now don't lose this negative in front of the x. It's negative x equals 1. If that was any number other than negative 1, you would handle it the same way. You would divide by the coefficient. So let's do that here as well. Divide by negative 1, divide by negative 1. X equals negative 1. Same math, different solution. Subtract 2, subtract 2. We have negative x equals, watch yourselves here, it's negative 5. Then divide by negative 1, divide by negative 1. X equals 5. Which solutions are correct? Both. So, moral of the story, isolate the bars before you separate the problem. Set up 2 problems. Fancy word, guys, right here when I made the answer, quote, a negative 3, that's called negating the solution. Fancy word. And then you solve them. Life is good.